Imagine looking up at a night sky, dense with shimmering stars, each one a sun to its own worlds, and wondering, could we share this vast universe with life beyond our planet? What if beneath icy shells and looming clouds of distant moons, life thrives in ways we can hardly imagine? Today, we delve deep into this profound question. Could life exist on moons like Europa or Titan? Hold your breath, because the journey ahead will reveal astonishing insights, radiant complexities, and perhaps a hint of mystery that even the greatest minds have yet to unravel. Trust me, you won't want to miss a moment of what's to come. Now, let's set the stage with Europa. This mesmerizing moon orbits Jupiter and has captivated the imagination of scientists and enthusiasts alike. Beneath its stark, icy surface lies a vast ocean, teeming with potential, hidden away from the harsh conditions of outer space. The thought of a subsurface ocean presents an unfathomable possibility. Could microbial life be dancing beneath layers of ice, oblivious to the vast cosmos just above them? You may find yourself pondering the patterns of life on Earth. Just as we found thriving organisms in the treacherous depths of the ocean, could something similar exist so close yet so vastly different from us? Don't forget Titan, Saturn's largest moon, where liquid methane flows in rivers and lakes and a thick atmosphere cloaks its surface. Here's something you didn't expect. Instead of water, Titan's lakes are composed of liquid hydrocarbons. Could life be thriving in sub-zero temperatures amidst such alien conditions? It forces us to rethink our definitions of habitability and life itself. What stands in the way of discovering the unimaginable? Could we even recognize life as we know it if we found it? Let's dive deeper into Europa's oceanic mysteries. Imagine a world where the surface is entirely covered in ice, concealing a water body that possibly exceeds Earth's oceans in volume. This ice acts as a protective blanket, potentially sheltering diverse ecosystems thriving where sunlight doesn't reach. NASA's upcoming Europa Clipper mission is designed to investigate these extreme environments. As scientists refine their instruments, they're eager to search for signs of habitability and even life by analyzing the icy surface and potentially puncturing through it. Isn't it exhilarating to think that the search for life is not merely a wishful reverie but an imminent reality? And yet, many questions linger. What if there is life beneath Europa's icy shell and it's unlike anything we've ever encountered? What forms would this life take? Microbial or perhaps something more complex? The intricacies of evolutionary processes could take astonishingly different routes under different conditions. What comes next will leave you speechless. If primitive life forms do exist on Europa, the implications could reconceptualize not just our understanding of biology, but our entire worldview regarding life's potential in the universe. Now, let's switch gears and fly over to Titan, an enigmatic realm of its own. Titan is an impressive destination featuring methane lakes and a dense atmosphere, showcasing an entirely different picture from the icy world of Europa. Incredibly, researchers are uncovering radical theories regarding the potential for life to flourish in such an environment. The research suggests that instead of carbohydrates, life on Titan could be based on methane, a notion that fundamentally challenges our traditional biochemistry models. As we contemplate Titan's frigid, hydrocarbon-dominated landscapes, one can't help but ask, how do chemical reactions differ in such environments? Is it possible that Titan harbors life forms that we wouldn't even recognize as life? The thought alone is enough to ignite wonder. Imagine life that thrives in freezing liquids, using entirely alien biochemistry, and communicating in ways we cannot fathom. Isn't that the essence of the quest, to understand the unknown? But the allure doesn't end there. Titan's unique vast expanses of liquids present an intriguing parallel to early Earth and its primordial soup, fostering thoughts of life's origins. Could the characteristics of Titan's atmosphere and surface provide a closer insight into how life began? Researchers are investigating how simple organic molecules interacted and evolved into more complex forms, raising vital questions. Can we learn about ourselves by studying the life-sustaining conditions of other worlds? Or is the question more profound? Might we be the interstellar visitors to a landscape that could birth life strategies unimaginably different from our own? As we navigate through this mesmerizing journey, let's take a moment to reflect on the role of astrobiology. This field of science is an extraordinary intersection that combines biology, chemistry, and astronomy, working fervently to decode the possibility of life beyond our home planet. Could understanding extremophiles, the organisms thriving in Earth's most extreme environments, provide clues on how life could exist under the extreme conditions of Europa or Titan? If life can thrive in Earth's boiling geysers or frozen Antarctic lakes, what's stopping it from existing in the icy ocean of Europa or the bubbling lakes of Titan? Remember, the essence of our quest reaches beyond mere curiosity. It's a search for companionship in this expansive universe. As we push the boundaries of human understanding, we foster a connection with the cosmos and our own earthly existence. You might be wondering what technologies are at our disposal that can aid our search. The answer is vibrant and thrilling. Space missions are now more ambitious than ever, equipped with advanced robotic instruments that will soon analyze the chemical signatures from these moons. The data collected could be the key to understanding if these distant worlds could indeed harbinger life. But don't rush to conclusions. We're only beginning to scratch the surface. Scientists have yet to identify definitive signs of life in our solar system. The whispers of interplanetary life are wrapped in uncertainty, asking us to tread carefully. However, the promise of what we may discover ignites hope in our heart. What if Europa's deepest regions unveil flashbacks of life's early stages, etching Earth's biological story across the canvas of the universe? How would such revelations reshape our understanding of existence itself? As we dissect the possibilities, it's essential to address a sentiment that many grapple with, the fear of exclusion. If life exists elsewhere, does that diminish the significance of our own? Could it be that life elsewhere enriches our existence, rather than detracts from it? The cosmos may offer numerous stories, and each one has the potential to stitch a new narrative into the colossal fabric of life's saga. Soon enough, we'll delve into the overarching question: what are the signs we should be looking for? Meticulous researchers have asked, what chemical signals or structures that hint at life can be detected? On Europa, scientists are focused on identifying organic compounds trapped in the ice, while Titan's atmospheric analysis may reveal the fingerprints of biological processes lurking beneath its heavy clouds. This entire discussion appeals to our innate curiosity and sense of adventure. The very essence of exploring these moons provokes a sense of mystery, inviting us to engage in an inquiry that could awaken an entirely new perspective on life. Yet, in the midst of these tantalizing possibilities, we must pay heed to the limitations of our knowledge. We envision potential life, but the truth is we don't know how common or rare it truly is. It's a balance of hope, skepticism, and sheer wonder that propels us onward. As we continue to unravel the enigma surrounding Europa and Titan, we must also confront the challenge of human exploration. The idea of sending humans to these icy worlds sparks excitement and trepidation in equal measure. Would we be able to adapt and thrive, or would our presence disrupt whatever delicate systems may exist there? The moral implications of our curiosity pose valid questions. Are we ready to shoulder the weight of exploring worlds that may be home to life forms? For now, the countdown begins for thrilling missions ahead. Closer to us than ever before, missions like Europa Clipper and even the potential for returning to Titan are taking shape. Exciting data awaits, and with it, the prospect of groundbreaking discoveries. What if we're on the brink of transforming our understanding of life and the unique ways it might manifest? Each new mission promises to push the envelope of our scientific comprehension and fill our nights with dreams of unfathomable ecosystems far from home. In the coming sections, we will delve deeper into how scientists plan to explore these moons in the pursuit of answers. We'll spotlight the thoughtful designs of upcoming missions, the tantalizing potential for groundbreaking discoveries, and the collective human commitment to understanding our cosmos. There's so much more to uncover, and I assure you, the adventure is just beginning. Stay tuned, as we take you further into the mysteries of Europa and Titan, igniting your curiosity and fueling your imagination. After all, the tantalizing question of whether life exists on such moons beckons us into the unknown, inviting us to unlock the secrets woven into the fabric of the universe. As we look forward to the unfolding exploration of Europa and Titan, it's crucial to examine the technological marvels designed to probe these celestial wonders. The upcoming missions are poised not only to investigate the chemical makeup of their surfaces but also to delve into their subsurface oceans and atmospheres. First, let's spotlight the Europa Clipper mission set to launch in the 2020s. This ambitious undertaking is equipped with a suite of scientific instruments dedicated to unraveling Europa's mysteries. Clipper's advanced radar systems will penetrate the moon's icy crust, identifying the thickness of ice and discerning whether liquid water exists beneath. Additionally, it will deploy spectrometers that can analyze the vapor plumes that may erupt into space, possibly releasing organic material trapped in the ocean below. Just imagine this spacecraft gliding around Europa, gathering invaluable data that could send ripples of excitement through the scientific community, revealing what's hidden beneath that cold, hard surface. The Clipper is a daring endeavor, igniting hopes of answering some of our most profound questions about life beyond Earth. Its mission isn't solely about finding life, it's equally about understanding the moon's geophysical properties and the potential for habitability. With each measure and each orbit, we inch closer to deciphering the clues inscribed in Europa's frozen landscape. The prospect of discovering life, even in its most primitive form, feels increasingly tangible as the wheels of exploration turn. In contrast, Titan exploration has its own thematic richness. The Dragonfly mission, also gearing up for launch in the coming years, is a groundbreaking venture that will deploy a rotorcraft lander to explore various locations on Titan's surface. This self-powered drone aims to fly to several diverse sites, analyzing the rich organic chemistry of its surface and, intriguingly, the peculiar methane lakes. Isn't it remarkable to think that a technologically advanced flying drone will navigate through the thick haze of Titan while sampling and studying its unique features? Dragonfly's array of instruments will search for prebiotic chemical processes that could parallel the early stages of life on Earth. Picture the excitement as evidence of complex organic compounds are discovered, potentially charting pathways toward how life could evolve in such alien environments. The mission's ability to scout varied terrains and sample different regions will offer unparalleled insight, potentially reshaping our understanding of astrobiology and life's adaptive mechanisms. Could we find conditions akin to Earth's primordial environments, a glimpse into life's original blueprint? Both Europa Clipper and Dragonfly symbolize our growing ambition to unlock the secrets of the universe. They embody the spirit of human inquiry, which yearns to identify our place among the stars. As instruments on these missions analyze chemical signatures, they aim to create a narrative of life's possibilities, each instrument meticulously gathering pieces of a cosmic puzzle. In the context of the search for life, astrobiologists are also studying how extreme environments on Earth inform our understanding of extraterrestrial conditions. Extremophiles, those resilient organisms thriving in Earth's least hospitable areas, such as deep-sea hydrothermal vents and acidic lakes, serve as indicators of life's versatility. They are proof that life can adapt to a wide array of conditions, suggesting that similar organisms could potentially exist in the ocean beneath Europa's icy crust or in the alien lakes of Titan. As we broaden our perspective, we must ask ourselves, how adaptable is life? Could it invoke different evolutionary paths, potentially giving rise to entirely distinct forms of existence? The concept of life as we know it might only represent a fraction of the myriad possibilities that exist across the universe. This leads us back to the question of how we define life. Would we recognize life based on its familiarity or on its behavior and reactions to environmental stimuli? Answering this question is essential for maximizing our chances of discovery. Navigating through the cosmos, one must also ponder the ethical dimensions of our exploratory pursuits. The desire to discover life is interwoven with the need for responsible stewardship of extraterrestrial environments. If we uncover life forms on Europa or Titan, how do we approach the responsibility of preserving their ecosystems? What protocols must be established to prevent contamination and the irreversible impact of human exploration? The ongoing debates surrounding planetary protection echo the gravity of these concerns. Scientists and ethicists are engaging in dialogues about how to safeguard the otherworldly environments from disruptions, thus ensuring that the exploration of these fascinating moons can occur without compromising their potential inhabitants. Plans must be set forth that encompass both rigorous scientific inquiry and the ethical imperative to respect the natural state of other worlds. As we engage in this quest for knowledge, allow yourself to envision a future in which we encounter extraterrestrial life. Consider the profound impact such a discovery would have, not just on our scientific understanding, but on humanity as a whole. It would serve as a catalyst for global reflection, possibly uniting us under a shared identity bound by our place in the cosmos. The realization that we are not alone could inspire a renewed sense of purpose among humanity. Multidisciplinary collaborations exploring astrobiology could also pave the way for innovative technologies and practices here on Earth. Equipped with insights drawn from other celestial bodies, we might devise sustainable systems that address ecological challenges at home. The pursuit of life beyond our planet could yield revelations that echo through the ages, prompting us to rethink our strategies for coexistence on Earth. But before we embark on this new beginning, it's essential to appreciate where we stand today. The tapestry woven through centuries of inquiry reveals that our cosmic narrative is just beginning. Every mission launched, every data packet analyzed, and every theory challenged solidifies our status as curious explorers insatiably seeking knowledge. The potential discoveries on Europa and Titan represent a broader promise, one that extends beyond scientific constructs, tapping into our essence as human beings. Ultimately, as we conclude our exploration of the life mysteries lurking beneath the icy surfaces of Europa and Titan, we are reminded that the essence of space exploration is not merely about finding answers, it is about the questions that propel us forward. The possibilities are as vast as the cosmos themselves. What we learn could very well challenge the foundations of biology, philosophy, and even spirituality. The journey ahead remains fraught with uncertainties and exciting prospects. As we anticipate the launches of Europa Clipper and Dragonfly, imagine the data, the findings, and the stories that will emerge. Each step we take brings us closer to understanding our universe, our origins, and perhaps, our place among countless other civilizations. Isn't it exhilarating to think that within the next few years, we might have glimpses into vibrant ecosystems thriving in alien oceans or methane lakes? The thought ignites a spark of hope, curiosity, and infinite wonder, a reminder that as we extend our reach into the universe, we are drawn closer to understanding what it means to be alive, not just on our planet but across the cosmos. So, as we stand at the precipice of this wondrous exploration, let us remain open to the possibilities. Whether we find life, remnants of ancient processes, or stunning geological phenomena, the journey itself is a celebration of humankind's spirit. Together, we chase the whispers of the universe, eager to uncover the stories of life that stretch across the vast expanse of time and space. The echo of our quest for life beyond Earth is a siren song, leading us to forge our destinies among the stars. And as we gaze up at the night sky, filled with shimmering potential, let us continue to ask, what lies out there waiting to be discovered, and what will it reveal about ourselves? Together, we hope to illuminate the darkness, igniting a legacy that transcends our time, carrying the promise of life's extraordinary tale throughout the cosmos.